This is one of the trickiest sets in the portion of this mock. Though it is not time consuming, solving all the questions of this set would not be an easy task considering the trick and complexity involved in this set. So that's all about the difficulty level of this set. Now coming to the nature of this set or content of this set. Here production of production at a cloth manufacturing plant involves the following stages. First one is W warehouse, A cutting, B rolling, C bleaching, D accumulating, and E charging. The sequence of working for a unit of product is E, D, C, B, and A. This is important because in the given order, when a unit goes through, it gets into a final product, it gets converted into a final product, and after this unit gets stored in the warehouse as the final product. Transfer between different stages of production takes negligible time, which means if a semi processed unit is transferred from E to D, time taken would be negligible or it would not be considered for practical purposes. Transfer of semi-processed unit between any two stages of production occurs at the end of 1 hour shift, which means a product cannot be shipped in between of 1 hour shift, and 1 hour is processing time during each stage, which means if a product is kept at some stage, let's say E at 10 a.m., then it can be transferred to next stage, that is in order of sequence to D will be possible exactly at 11 a.m. After that, final product are transferred out of warehouse only at end of day, that is 4 p.m. The warehouse can store any number of units, that is it doesn't have any capacity constraint. Following is work capacity of cloth manufacturing plant during different shift of the day. Now from the table it can be noted that the processing at different stages of production at different times is given in the table. The number of unit that E can process at between 10 to 11 is 2, and that of D is 6, C4, B1, and A is also 1, and the number of unit that D can process, let's say at time between time 2 to 3, it will be 5. So the information given in table can easily be understood. It is also known that at 11 a.m. or 10 a.m. A, B, C, D, and E stages have 1, 1, 4, 6, and 2 units respectively. There are no units kept in the warehouse at 10 a.m. and outstanding is defined as the number of unfinished units at any stage of production which cannot be processed due to capacity constraint, which means if D receives 2 units at 11 a.m., then outstanding will be 1 because its processing capacity is only 1 at 11. So this is what we need to understand about outstanding. And now it is also given that if capacity permits, the outstanding of any shift can be processed during the next shift, which means if one unit at D lying as outstanding between 11 and 12, it will get processed in the next shift, that is 12 to 1. If there's no issue of capacity constraint. In first question, we are asked to find the maximum possible number of product that can be stored in the warehouse at 3 p.m. As we know that the order in which units gets processed is E, D, C, B and A. So the units which are at E at 10 a.m. will get processed or will become final unit at 11 a.m. and the unit at other stages will keep going through. Instead, the unit at A bit, between 10 and 11 will get converted into a final product, and at V it will get shifted at 11 from this stage to stage A. The same will take place with the units at other stages. So now we need to see the number of units at 10 am at stage A, because it is the final stage and it has one unit. Therefore the number of units that will have as finished product at 11 am will be 1. Now the number of unit which gets processed at B between 10 to 11 will be shifted to A at 11, and it will get converted into final product at 12. The number of unit at B between 10 and 11 is 1, and the number of unit that A can process between 11 and 12 is 3. So it will easily process the unit that it get from B. Now coming to stage C, it had 4 unit between 10 and 11, and it gets shifted to B at 11, and it capacity of B at between 10 and 11 and 12 is 6. So all these 4 units will get processed and they'll move to stage A at 12, and the capacity of stage A between 12 and 1 is 4. So all the 4 units that are at C between 10 and 11 will get processed as final unit between 12 and 1. Now coming to D, it has 6 units at 10. At 11 these 6 units will be shifted to stage C, and its capacity is 6. So all these units will be processed, and when these 6 units are transferred at B, which capacity at between 12 and 1 is 3, so only 3 units will be processed at this stage, and the rest of the 3 unit will be there as outstanding. And out of these 3 process unit, when they shifted to A, only 2 will get processed and 1 will be as outstanding. So between 1 and 2 only 2 units gets processed. Now while these 2 units shift, shifted to are being processed at stage B, the outstanding at B between 12 to 1 will get processed at the same stage in the next shift, that is between 1 and 2, and the unit which is there at A between 1 and 2 will get processed between 2 and 3 at the same stage, and the 3 process unit at stage B between 1 and 2 will be shifted to stage A at 2, and these 3 will get also processed as capacity of this stage is 5. So all the remaining units of initial stage of C will get processed between 2 and 3, so 4 more units. Now coming to the stage E, similarly we can follow this same logic that we did for stage D, and we find that the 2 units which we initially have at stage E will get processed before 3 or by 3. So the total number of unit that gets processed as a final product between 2 and 3 is 4 plus 2 6. Therefore the total number of finished product or final product that we will have at 3 is 13. Therefore option D is the correct answer. Now coming to the next question, here we are asked to find which stage of production will encounter outstanding for the first time. There would not be a case of outstanding between 10 and 11. Now coming to 11 o'clock, if we see at stage D, which processing capacity is 1 but it receives 2 unit from stage E, so D will encounter outstanding at 11. So D could be a probable answer if there is no other stage where outstanding takes place between 11 and 12. And if we look at option, there is no such option like D and C or D and B blah blah. So from here we can be 100% sure that our answer is D. But just to check whether there is possibility of outstanding at any other stage at 11 or not, which is not, because when 6 units are transferred from D to E at 11, which 11 and capacity of C is 6, so there won't be any outstanding. Similarly we can check for stages B and A as well, and we won't get any outstanding at 11. So D is the stage which encounters outstanding first. In next question, it is given that, or in fact it is a hypothetical condition where we have only two stages, namely E and D, and it is asking what would have been the maximum possible number of final products that can be stored in the warehouse at 4 p.m. These the final stage of production, and at 10 a.m. E and D have 2 and 6 units respectively. Now here there are only two stages, and D is the final stage, E is the initial stage, and we have to maximize the number of finished product that can be produced till 4. So look at the number of units at D between 10 and 11, it is 6. So all these 6 units will be final product at 11. Now coming to stage E, which has 2 units at 10, and when these 2 units are shifted to stage D at 11, one unit will get processed as final product, and the remaining unit will remain at the same stage as an outstanding. And we know that the processing capacity of stage E at 11 or between 11 and 12 is 6, so we can place we can consider there are 6 units at 11 at stage E, as we have to maximize the total number of finished product. And when we look at the processing capacity of D between 12 and 1, we find it is 5, but we'll have 6 7 units for processing at this stage. 6 that is transferred from E to D at 12 noon, and 1 unit is already at stage D as an outstanding. So out of these 7 units, 5 will be processed as final product and 2 will remain there as outstanding. And we need to keep repeating the same process, like at 12 we have 4 units at E that gets processed by 1, and when we transfer these 4 units at stage D, which already have 2 outstandings, so 2 plus 4, that is 6, will have 6 units at D at 1 p.m. Out of these 6, 2 will get processed and 4 will be there as outstanding. There are the capacity of E at between 1 and 2 is 2, so at 2, 2 units will be transferred from E to D, which already has 4 units as outstanding. So total unit of product at D at 2 p.m. is 6. Out of these 6 units, 5 will be processed as its processing capacity is 5, and 1 will still be there as an outstanding. At 3 a.m. p.m. will receive 5 units from from E, and we have 1 unit as and outstanding, so total units available or present at D at 3 is 6. Out of these 6 units, 4 will be processed as final product and 2 will remain outstanding. So the total number of finished product that will have at the end of 4 p.m. is 6 plus 1 7 plus 5 12 plus 2 14 plus 5 19 plus 4 23. So a maximum of 23 units of product can be had as finished product at 4 p.m. Now coming to the final question, it is almost identical to the previous question. Here two stages of production are B and A instead of E and D, and again we have to maximize the number of finished product or final product at 2 and A has 1 unit and B also has 1 unit at this time, and B is the final, instead A is the final stage of production. Again we need to do the exactly same thing what we did in the previous question, and after doing that we get the maximum possible units as 8, which is option A.